curve, well, that's what that's known as. It's defined using the mean, which is this funny little letter here. It's a fancy M. I know it looks like a U. And standard deviation, which we have seen before. Okay, it's symmetrical, which means that the mean, median, and mode are all the same, and it's stuck in the middle here. Right. Okay. This is fancy terminology that you may see at the start of a question. This says that the value x, so our data, so this x stands for the data, is the n stands for normally distributed. Okay, so if it's normally distributed, you may see this fancy n. They may have the mean value and then the, does anyone remember what this stands for when it's the standard deviation squared? The variance. Yeah, so this stands for the variance, or it may have the mean and the standard deviation. The question should be clear which information they've given you. Right, we use the normal distribution to find the probability of events. Okay, so this is a side part of the probability topic. So if you're keeping things separate, then you want to put this in a probability section. It's been found that the percentage of a variable within one standard deviation of the mean is 34.13%. Okay, so if we knew the value of the mean, so let's pretend it's 12, and that the standard deviation was 2, that we know that between the values of 12 and 14, 34.13% of the data would occur. Okay, does that make sense? So that stands here for one standard deviation. Obviously that's 2 and 3. So this is the mean subtract one standard deviation, 2 standard deviations and 3 standard deviations. Essentially, to the right-hand side of the mean, we know that 50% of the data is going to occur, and on the left-hand side, again, 50% of the data is going to occur. I haven't seen a question where you need to learn these numbers, so hopefully none would ever come up. Okay, and generally they're on the calculator question, they're on the calculator paper, so you would be using your calculator to do this. I haven't seen on the non-cap. All right. We know that probability totals 1, and as I said, either side is 50% or 0.5. Okay, so far so good. This not so important to recognize. It just shows you the difference that it would make if to have different standard deviation values. Okay, so we were saying up here how that this, oh no, gone too far. Oh no, why is this not aligned? Right, so as I said here, it's all based on the mean and adding standard deviations and subtracting them. Okay, so we know that generally within 3 standard deviations, most of our data is going to occur. So if our standard deviation is 1, which is the blue one, it's flatter. If our standard deviation was this purple one and only 0.3, then obviously it's going to peak up at the top. Does that make sense? Because the distance away is going to collect all of our data. Okay, so it's not really important, it's just something to get you to visualize what's happening. The curve flattens, the standard deviation changes because the area has to equal 1. And if the data has different mean values and standard deviations, it makes it difficult to compare. So some cases we would look at the standard normal distribution. Okay, now these kinds of questions have changed in recent years because it used to be that you would always have to change things to be standard normal distribution and then look things up in a table at the back. But that table has now been taken out and they rely on people using their calculators to do all of this. So the type of question that you may see in the past, or I think it was maybe it was pre-2014, and will be slightly different because the formula booklet was different then. Okay, so any that are post 2014 are the kinds of questions that you would have. Now, what am I on about? Standard normal distribution. Well, the standard normal distribution changes all data so that we pretend, if you like, that the mean of that data is 0 and the standard deviation of that data is 1. Okay? Is all this information on there? So, yeah. Okay, so as I said, so when we're standardizing, what it's doing is it's changing the data to kind of pretend that the mean is 0 and the standard deviation is 1. It's a little bit like how when you have test scores, sometimes they're out of 20, sometimes they're out of 75, 79, whatever. In order to compare them, we need to have them as a standard piece of information. So we generally change them to percentages. For standard normal distribution, in order to compare things, we change them to be the standard normal rather than just normal distribution. Okay? So if you see anything with the mean of 0 and the standard deviation of 1, you know that it has been changed to the standard normal distribution. Now, in normal distributions, we will be talking about x values. Okay, for standard normal distribution, whilst it says x there, we are actually talking about z scores. Okay, so whenever I talk about a z score, this z secretly represents the information that we're going to show on our graph. Bless you. It all starts to come together when we do examples, and I know there's lots of letters and lots of things that I'm talking about at the moment, and it's not really coming together until you actually see it in play. So this formula you get given, so the x represents the data that you're going to be changing, the mean and the standard deviation, those symbols are there, and that changes that to be a z-score. So as I've said here, whilst you no longer need this formula to convert the values, you'll need to use it in some questions. So they do expect you to be able to use that. All right, we can use our GDC to find these probabilities of these events happening. So I'm just going to focus on standard normal distribution information. I'm not talking about real data, I'm just talking about standardized stuff. So my suggestion to you is just to, whenever you're doing a question, you're just going to sketch a little bell-shaped curve. Now when I say sketch, I really mean sketch. Like full-on, 2-second, quick diagram. Just to get a visualization of what's going to happen. If this value here is 0, where would the value 0.56 be? Is it going to be on the left of it or the right of it? The right. Okay, it doesn't matter how far away. I know it's going to be there. Yep. I'm trying to find the P. The P stands for probability that our z-score is less than, we all happy this means less than, 0.56. So if it's less than that value, it would be this area here. You all happy with that so far? Ali, can you tell me something about the probability of that? The number of it. Remember what we talked about up here about rough percentages. Can you tell me anything about the probability of this shaded area? That's not a really good question.
Could be like it's more than 50%.
Yes, that was what I was looking for. Thank you, Joshna. We know that our value here has got to be more than 50% because it's more than half of the graph. Yes? You're happy with that? Okay, so identify where the z-score is in comparison to the mean. We did that. Shade the area you're looking for. Check. And we're now going to use the GDC. Okay,